Hi, today I'll be talking about trigonometry. Trigonometry is a branch of mathematics that studies relationships between sides, lengths, and angles of triangles. It's a very broad topic, so I'll only be shortly discussing them. Quick reminder, a triangle has 3 angles, one at each vertex, bounded by a pair of adjacent sides. The sum of these angles is 180. So, I'll be discussing the law of sines and the law of cosines. First, we'll have the law of sines. For any triangle ABC, it says that sine A over A equals sine B over B, and then sine C over C. Or alternatively, A over sine A equals B over sine B, and C over sine C. I'll be giving an example. We are given this triangle ABC, with the angles 45 and 65 for A and B given, and the side opposite A, 18. So we'll be looking for B. We'll be using the formula B over sine B equals A over sine A to solve this one. Just substitute what was given with these things, so that would be B over sine 65 equals 18 over sine 45. We're going to manipulate the formula to get B alone so that we can find out what it is. Okay, so once you've done all that, you should get 18 times sine 65 over sine 45. When you compute this in a calculator, it should show 23 centimeters. And that's the measure of side B. You can use the law of sines to solve AAS and ASA, which is triangles that have angle, side, that's equal to another triangle with the same angle, side, and ASA, which is angle, side angle, that's equal to another triangle with another angle, side angle. I'll be giving one example. Here we have a triangle ABC, given A, the measure of angle A, 65, and the measure of angle B, 65, and the side opposite of angle C, which is 13.1. So before we start, we're going to be using this formula, but we're missing the angle for C. How do we get this? Remember, the sum of a triangle is 180 degrees. We already have 2 of these angles. So we add them, 65 plus 65 is equivalent to 130, and that should be 180 minus 130 equals 50. So the measure of angle C is 50 degrees. Now we can substitute. So sine 50 over 13.1 equals sine 65 over A. We'll be solving for A. Again, manipulate the formula so that you can get A alone, and once you do that, it should look like 13.1 times sine 65 over sine 50. When you're done computing that, it should be 15.5. B is also 15.5 because A and B have similar or the same angles, 65 and 65, so they should have equal sides. Okay, I'm done with that. So we'll be moving on to the law of cosines. This is a bit long. For any triangle ABC, it says that A squared equals B squared plus C squared minus 2BC times cosine A, and then for B, it's B squared equals A squared plus C squared minus 2AC cosine B, and then C squared equals A squared plus B squared minus 2AB cosine C. It's a bit long, but all you have to do is substitute. For example, we're given this triangle ABC, given the measure of the angle A, that's 85, and the measure of the side opposite B, 19.5, side opposite C, 10.8. We'll be finding A. So we're going to use A squared equals B squared plus C squared minus 2BC times cosine A. Just substitute what was given. So since we're looking for A, we'll move to B. The side opposite the B, 19.5, substitute. So that's 19.5 squared plus C squared. The side opposite C is 10.8. So 10.8 squared minus 2 times BC, substitute, 19.5 times 10.8. So 2 times 19.5 times 10.8 times the cosine of A, 85. So the cosine 85. Once you've done all that, it should be A squared equals 496.89 minus 421.2 times the cosine of 85. We're looking for A. We still have A squared. It's easy to solve this. We should just square everything. So you get that 2 out, and it should just be A. And then once you're done computing this, the answer should be 21.5 centimeters. And that is the measure of angle A. So like the law of sines, you can use it to solve triangles. But for the law of cosines, you use it to solve SSS, which is angles that have 3 sides that are equal to each other, and SAS, triangles that have angle side equal to another triangle with the same side and the same angle and the same side. I'll be giving you an example. Given this triangle ABC, you're given all the sides. The side opposite A, 11, opposite B, 9, opposite C, 8. So we'll be first solving for the angle of A. So A squared equals B squared plus C squared minus 2BC times cosine A. Substitute everything. So that's 11 squared equals 9 squared plus 8 squared minus 2 times 9 times 8 times the cosine of A. So once you're done computing this, it should be 121 equals 145 minus 144 cosine A. So again, when you're done computing, negative 24 equals negative 144 cosine A. You're going to manipulate the equation to get cosine alone. So that would be dividing each side with negative 144. Negative divided by negative is positive. So that would be 24 over 144 equals cosine A. To get the angle, you need to input in your calculator A equal arc cosine 24 over 144. When you do this, you should get 80 degrees. So A, the measure of angle A, is 80 degrees. For B, it should be B squared equals A squared plus C squared minus 2AC times cosine B. Okay, again, you just substitute what was given. So that's 9 squared equals 11 squared plus 8 squared plus 2 times 11 times 8 times cosine B. So once that's done, you should get 81 equals 185 minus 176 times the cosine of B. And again, negative 104 equals negative 176 cosine B. Again, manipulate the formula so you can just get cosine B. So that should be 104 over 176 because negative divided by negative is positive. And then again, in your calculator, arc cosine 104 over 176 would be 54. So you have 80 for A, 54 for B. If you want to know C, you don't need to go through this long route. Since you already have 2 angles, again, the sum of a triangle is 180, so you just add these two. 80 plus 54 is 134. Then you subtract that with 180. 180 minus 134 is equivalent to 46. So that would be, the measure of angle C is 46. And that's it for now. Bye.